Thanks everyone for coming. It's great to be here. My name is Gabor Szarnyas, and I'm a developer relations advocate at DuckDB Labs. And tonight I will talk about DuckDB and some short examples with DuckDB and dbt. Briefly about my background. I spent a decade in academia. I studied here at the Technical University of Budapest. Then I moved to Amsterdam in a research institute. And that research institute happened to be where DuckDB was created, so that got me close to DuckDB. During research, I worked on benchmarks for graph database systems. I designed benchmarks that measure the performance of analytical graph databases. And now I'm sort of the chronicler of the DuckDB project. I edit the technical documentation of DuckDB, and I contribute to and edit the blog of DuckDB. So what is DuckDB? In a single sentence, DuckDB is a universal data wrangling tool. It speaks SQL, you can do analytical queries on your tabular data, and it runs in process. How many of you have heard about DuckDB before? Okay, so it's a grateful audience, it's 80%. So I chopped all the slides that are the high-level overview of DuckDB, and I want to talk about more the deep dive and in-depth questions of DuckDB. First of all, why did we choose an in-process architecture? The in-process architecture stems from the observation that the traditional client-server divide, which works really well, has a few inherent drawbacks. One is that someone has to operate the server, so that already incurs time and money costs. Second, someone has to set up the server and the connection, which is cumbersome. You need to authenticate, you need to copy tokens around. That's just not nice. And then the third is that these arrows in between actually form a huge bottleneck. If you want to fetch a table with 1 billion rows and the computer is sitting in AWS EC2, you have to download it. It's going to be expensive. It's going to be slow. So DuckDB takes the database and brings it into the client application. And when it does so, it's very easy to connect to. You just say import DuckDB, and you have your DuckDB instance. And most people just run DuckDB in an in-memory setup, so it's very comfortable and very easy to interact with. This is what I call a truly serverless architecture, because in Snowflake, even if you choose serverless, there is always a server. Here, DuckDB is just sitting on your laptop. People think DuckDB is an in-memory database, and while it can work in memory, it's primarily a disk-based database. In fact, it has a format where we use a single file database, so all your data is in one file. Can you hazard a guess where we got this idea from? This is SQLite, correct. SQLite with 1 trillion deployments, the most popular database project, or maybe the most popular software project, was the inspiration of DuckDB. And the way we like to think about where DuckDB belongs in the area of database systems is that DuckDB has the form factor of SQLite, so it's in process and it has a single file format, but it has the workload style of Snowflake, so it's geared toward analytical queries. Let's move on to the internals, mainly storage, execution, and the indexing of DuckDB. So DuckDB has a column-based storage, which means that unlike Postgres, MySQL, and SQLite, which do row-based storage, where every row is stored physically together on disk, DuckDB uses a columnar storage. This has a bunch of advantages. For example, we have this railway dataset where we have some dates, some train stations, some of the delays that the trains have accumulated, and we have organized this in a columnar layout. And what you can see on the slide is that this data, like quite few datasets, is actually sorted along the date column, so it's ordered along the date column, meaning it's very easy to compress it. We can use something like a delta encoding and just turn it into a single integer with a starting value. Similarly, sometimes the delay is 0 because we had a lucky day and the trains were on time, and then we can just compress away the entire column in a single constant value. So this can save a lot in disk storage. Execution-wise, there is also a big difference. The two main ideas that would come to mind is to do tuple-at-a-time execution. You can read the first row, do your processing, read the second row, the third row, and the fourth. But this is difficult to parallelize, it's prone to cache misses, and it's usually not how modern CPUs like to execute code. Column-at-a-time operations, on the other hand, are great. You can just put all your dates in, and then you can aggregate on them, and then you can do the same on the delays. But this is prone to running out of memory. This is the reason why pandas runs out of memory. Pandas has a column at a time execution, and if you have too much data, it will just simply crash because it runs out of memory. So vectorized execution is kind of an in-between approach. We try to reap the benefits of columnar execution by taking chunks of the data. These chunks are the vectors. In DuckDB, this means 2048 entities are in every given vector, and then we iterate along those vectors. And these vectors are actually quite great because these allow us to chunk the data along these vectors and then distribute them along the row groups of the data to the different CPU threads. And modern CPUs have quite big L1 caches, meaning that with the rightly chosen vector sizes, all the vectors for a given operation, for a given chunk, fit into the L1 cache of the CPU. And of course, the L1 cache is much faster than the L2 cache, the L3 cache, and the main memory. So 32 to 128 kilobytes is actually quite a large amount of memory if the data has this compressed columnar layout with vectorized processing. And one of the things that people like to ask is, why didn't DuckDB exist 15 years before? And one of the main answers is that you need a modern CPU compiler to auto-vectorize your code. We make sure that our code uses tight loops, we use branchless code, so that the compiler can do its magic and turn it into SIMD, single instruction, multiple data instructions. This is something that is only available in modern compilers roughly 10 years ago. 15 years ago, you would have to do it in basically writing SIMD intrinsics, which is not much easier than programming in assembly. If you run your workloads on a laptop, I found that you can usually read a CSV file from the laptop's disk into DuckDB's native database format at more than 1 gigabytes per second. In 1 hour, you can complete something like the TPCH benchmarks queries. This is a well-known and rather rigorous benchmark that's designed to torture databases and is designed for analytical workloads. And this can run on a modern MacBook on the scale factor 3000 dataset, which is 3 terabytes of CSV files. This is something that 10, 15 years ago was the territory of big iron workstations that you bought for hundreds of thousands of dollars, and now it works on a MacBook. It also works in other places. DuckDB is really proud of its portability. DuckDB has a bunch of clients for languages like Python, R, command line, NPM Java, and so on. And DuckDB also runs on Macintosh, Linux, and Windows. DuckDB is so portable that you can compile it to WebAssembly, and then it runs in your browser. And it also runs in the browser on the phone. You can just type shell.duckdb.org in your phone's browser, and you can run SQL queries as shown in the example. A bunch of neat features about DuckDB. I promise that I will talk about indexing, and kind of the counterintuitive thing about indexing is that people learn in graduate school that you should put indexes in your data if you want to make queries fast. This is very true for transactional systems if you know the queries in advance. But in analytical systems, it's usually not a good idea to over-index your data. It will cause the loading phase to be very slow. It will cause the updates to be slow. And sometimes it doesn't even help the queries. What does help the queries is to have some sort of lightweight indexing to help pruning. And this is quite similar to the micropartitioning figure that Tibor has shown. Here we have a date column, an ID, a station, and a delay column. And for every single one of those columns, for every single row group, we store the minimum value and the maximum value. And why is this great? This is great because if you say, I want something about the trains that ran during the summer, we can just look at the minimum and the maximum values, conclude that this is only row group 2. Only row group 2 on the right has trains in the summer. And then we can further prune along the columnar storage. And that means we can basically just read 1/8 of the data compared to reading the 2 row groups. DuckDB supports quite a few formats and protocols. We do CSV, Parquet, and JSON, which are the standard textual and binary formats, and we do Delta and Iceberg, which are the lakehouse formats that are getting increasingly popular. We can read data through HTTP, HTTPS, S3, and from the Azure Blob Storage. And we can also connect directly into databases and run analytical queries using DuckDB's engine, but reading from the storage of these systems. And finally, we integrate quite tightly with the data science world. You can run DuckDB queries on Pandas, NumPy, or DuckDB with dplyr. And the nice thing about all these integrations is that DuckDB is kind of the fabric in the middle that weaves these together. And what this means is that these integrations usually work in synergy. For example, you can read something like a remote S3 or HTTPS stored Parquet file, and the same tricks that I showed about DuckDB's native format, meaning that it can prune along the columnar layout and the min-max indexes, this works well even if you query a Parquet file on a remote endpoint. And this is thanks to some quite obscure things in the HTTP standard. That means you can formulate your HTTP requests in a way where you have range requests just seeking into the file and reading given bytes of the HTTP endpoint. DuckDB also has something called friendly SQL. So DuckDB speaks a dialect based on the PostgreSQL, and that's actually something that helped us a lot with integrating with other tools. But of course, Postgres is not perfect, and if you have something like this, which is a matrix of the train station differences in the Netherlands, and you would try to turn it into something from a wide table to a long table, which is very popular and common in data science operations, you would need to write something like unpivot on and then list all the train stations, 400 or so. DuckDB has something called onColumns, which the columns asterisk expression is substituted to the list of columns in the table, and then you can exclude given columns of it. So this is a really neat and short way of expressing it. DuckDB also has something called create or replace, which is increasingly common in modern SQL dialects, but not supported by systems like Postgres yet. Create or replace is neat because we can write these idempotent scripts with it. You can just keep running your script, and it will always replace the tables. If it crashes halfway, you don't have to throw away the temp tables, just write over them in the next run. And something that we announced yesterday is the DuckDB local UI. So most people so far have interacted with DuckDB using either the command line client or Python or a Python notebook. But now you can just launch DuckDB with the DuckDB-UI flag, and it will run this internet browser-based neat user interface where you have notebooks, you have a table analyzer, and you have your SQL editor in your browser without doing cumbersome magic in the command line. This is, of course, DBT Meetup, so let's talk about DuckDB's DBT integration. This was a use case that we like to think of as a pipeline. The three major DuckDB use cases is interactive analysis for data science, creative architecture where people run DuckDB on Raspberry Pis, on phones, smartwatches, and smart TVs. But DBT falls in the middle with the pipeline components, where it's not an interactive setup, it's just DuckDB that's spun off quickly, then it does something, usually in in-memory mode, and then it just shuts down. So DBT DuckDB was originally developed by Josh Wills in Silicon Valley, and he used it for a pet project and ended up using it for some epidemiological use cases too. DuckDB fits DBT really well because it's lightweight, it can be started quickly, and it is rather fast. And when I tried to come up with an example of how I would use DuckDB with DBT, I was reminded of this use case of mine where we had large graph datasets, and I inherited a code base which generated them with Hadoop. And of course, it was rather difficult to work with and very slow. So we migrated it to Spark, and it was still rather difficult to work with and very expensive to run. We spent tens of thousands of euros running Spark jobs. So ultimately we said, okay, this is obviously no way to live. Users will not go through the hoops of getting all these AWS quota increases and running the Spark jobs of AWS. So we said, let's just pre-generate the data. But what then happened is that we had this combinatorial problem of let's generate all sorts of different layouts with all sorts of different date formats. And we ended up distributing 8 somewhat similar but different layouts for the data. And this grew to a size where it was tens of terabytes, and it was so expensive that I had to talk to a research institute to store it on tape. So this is somewhere in Amsterdam, and if you want to download it, you have to fetch it from tape to disk and then from disk, which is obviously not nice. So I have been wanting to reduce the size of this for some time, and one thing that is something that we should have done in retrospect is obviously move from CSV and compressed CSV files to a nicer compressed binary format like Parquet. So I did some experiments, and it turns out that CSV is very easy to beat, of course, with Parquet. But if you do compressed CSV, that's around 3 megabytes, that's quite difficult to reach. So for that, what I ended up doing was I used DuckDB and I changed to our new Parquet version, which has been supported as of the latest DuckDB release, and I turned on the ZSTD compression, which then managed to be under 3 megabytes. So this is overall a 4x save. And then I created a simple DBT file, and I created an input model that just reads the Parquet, and then every single layout is just one SQL query, which takes the input and then creates an external materialized table and writes it into the CSV. And this is basically the whole DBT model. You can run DBT build on it, and this is something that takes less than a second. And this is where the lightweight, dependency-free nature of DuckDB really comes at play, because obviously with these small data sets, the processing time would be fast both in DuckDB and in other systems like Spark. But for Spark, you have this big overhead of setting up the system, starting, waiting for it, and so on. DuckDB does everything combined with less than half a second. And the neat thing about the DuckDB UI, which I found out during debugging, is that you can just find the dev.duckdb file that dbt.duckdb leaves, connect to it with DuckDB-UI, and then you can peek into the import and the export tables and just troubleshoot your queries, which is, again, much nicer than working with Spark and something that is on a remote endpoint with a big delay. So what's the business model behind DuckDB? This is something that people usually are curious about. DuckDB is developed by a company called DuckDB Labs. This is where I work. It's based in Amsterdam, and we are a small team of roughly 15 people. And the interesting thing about our business model is that we are not funded by venture capital. We are plainly funded by revenue, and that revenue comes from other companies which we provide consulting and support services for. And many of those companies have venture capital. So we work with MotherDuck, we work with Databricks, and so on. And if you follow the database world, in the last 5 years in particular, it has been very common for companies to do a license change. MongoDB changed licenses, so did Redis, Elastic, Neo4j, and so on. And this is something that users are quite concerned with. So to alleviate this concern, we actually moved all the intellectual property of DuckDB to a Netherlands-based foundation. This is called the DuckDB Foundation, and this owns the IP of the project. So we cannot relicense it because it's not part of the DuckDB Labs organization, it's in the foundation. Even if Labs gets acquired by a big tech player, it stays there, and it stays MIT licensed forever. The foundation is funded by donations from contributors, companies like MotherDuck, Posit, who develop RStudio, and Positron, and Voltron Data, who are very active in the Arrow ecosystem. And speaking of MotherDuck, MotherDuck is our close partner company, which is a venture capital funded American company based in Seattle. MotherDuck does this weird trick where we said, okay, let's not do the client-server architecture because it has all these inherent problems, and DuckDB is this simple embedded system. MotherDuck takes that system and says, well, actually, those things are rather useful if you want to collaborate with people, if you want to work in the cloud, if you want to share your data, and it builds back many of those components in the cloud. So MotherDuck is a DuckDB-based cloud data warehouse with quite a few cool ideas, like hybrid query execution, where one part of the query runs locally, maybe having access to your sensitive personal health data, and the other part of the query runs in the cloud and has access to some open data set. So to sum up, I like to think about DuckDB as a kind of good old school system. DuckDB would feel at home in a research institute's old CentOS machine 20 years ago because it is open source, it runs from the command line, it is built on open standards, and if you open the DuckDB website, we go to great lengths to make sure you have a smooth experience. We don't have cookies, we don't have telemetry, you can download our documentation and it works offline. And if you think about this spectrum of data processing systems, we like to say that DuckDB is positioned around the middle. Obviously, for small data sets, Excel and Pandas are great. And for large data sets, Spark is also great. But with DuckDB being increasingly more popular and having more and more integrations, you can now read Excel files with DuckDB, you can read pandas with DuckDB, and with DuckDB being more and more scalable, I think DuckDB is pushing what's doable on a single machine and leaves Spark only for the 10 terabyte plus big jobs. And Spark and the DuckDB integrates really well with dbt. Thank you, and if you're interested, follow our socials, and I'm happy to answer any questions. Q&A questions. Question 1, DuckDB runs on CPU. Any plans on supporting GPU-based calculation? So this comes up quite frequently because you have pretty amazing GPUs in computers, mostly thanks to the AI boom, but this would hinder the portability of DuckDB. So we have thought about this, and there are currently no plans of doing GPU calculations because of the portability issue, and also because GPUs are only really good at fixed size data. As soon as you hit something like strings, it starts to become more and more cumbersome to program them, and then the benefits kind of start vanishing. Second question, full Delta support, read, write, Unity catalog when? When someone steps up and funds it. That's part of the roadmap, but our roadmap has a big part that says open for funding, and this is full Delta support is one of them. Your new local UI is awesome. Do you plan to open source it? Will you add the SQL formatter for lazy people? So the UI is shipped as a DuckDB extension, and that's open source. The component that runs in the browser, the JavaScript, that's not open source. Obviously, you get the source, but it's an obfuscated piece of JavaScript source. I talked to the developers yesterday, and we are considering open sourcing it. It's going to be a bit difficult to do that, but it is under consideration. Will we add the SQL formatter? I have seen a SQL formatter a couple of days ago. I think it's in the awesome DuckDB repository. And someone also developed a formatter as a DuckDB community extension where you just write a query and then it prints you out the nicely formatted one. But this is not part of the UI yet. And the last question is, I read some interesting news lately about distributed DuckDB small pond. Do you think it will get traction? So this got a big attention because it was done by the Chinese company DeepSeek, who got famous because of their R1 model. It's a bit early to tell whether it will get traction. The thing about it is that they built this stack with their own distributed file system and with their own distributed orchestrator for DuckDB that uses Ray internally. And they got quite a bit of attention. What I read from the comments is that people are a bit skeptical about this becoming an industry standard. So even if their distributed file system, for example, has some inherent benefits, you wouldn't really move over compared to something like AWS S3, because S3 is the industry standard and this is a shiny new idea. So I think this is something that hackers will experiment with. It's not necessarily something that you should start using in production just yet. But this is very interesting. And if you can program it meticulously and if you can make sure that small pond can execute your queries, this will alleviate a lot of the scalability issues that people say. If you have a petabyte of data, then you shouldn't use DuckDB alone. Maybe with small pond, you can actually make sure that your queries finish. All right, any more questions? All right, seeing none, I hand back the microphone back to Altan. Thanks.
Thank you.